Good morning. This is our second day of class online. I've decided, because my calendar has 4 sections, it's kind of hard uploading all the videos. So I'm going to do these 2 sections. Then I'll do 2 more sections tomorrow because the videos, for some reason, were kind of hard to upload. But anyway, I hope you all are having some good family bonding at home. I'm sure it's been trying for some of y'all, as it has been in the Scoggins household a little bit. My kids are really not happy about this, but I think it's good for us sometimes. So in light of that, the verse is for me, the verse is for you. Be still and know that I am God. I will be exalted among the nations. I will be exalted on the earth. Psalms 46:10. I think this is a reminder for us to be still during this time and to just reflect on whatever God has planned and keep praying for our nation. And obviously, He is being exalted and acknowledged upon the earth, so I think God is using this for that. And that's your scripture for today. We are moving on to a new section. We're getting into what you call trigonometry. We just left geometry. Trig is the study of triangles. I know that's really a hard, big word, but it's not really that hard, except it just sounds difficult, and it's really not. But it's the study of triangles. Today we're going to start with section 9.1. I want to point out too, went ahead and put up the homework. It's on your calendar, and like I said, I'm going to try to do these 2 sections today. And then tomorrow, I will do the other 2 sections because we're doing it all video. So, homework is going to be section 9.1, practice problems 1 through 8 all. Sections 9.2, practice problems 1 through 10. You do them however you and your parents decide. You might want to do 1 today, 1 tomorrow. You might want to just slow down these sections because you absolutely can under these circumstances. But today we're doing the Pythagorean rule and trigonometry. Pythagorean rule. And as I said, trigonometry. So trig, the easiest way for me to always remember it, trigonometry is the study of triangles. When I was in high school, you didn't take pre-calculus, you took trigonometry, because these triangles are absolutely amazing. Some of y'all probably don't care too much about that, but it really makes sense. And I hope I can just give you a little bird's eye view, because obviously this is not going to be the whole scope and sequence when they have a whole class devoted to this, but triangles and perfect squares are amazing. This rule I'm going to give you, you can actually use if you were out in the woods and you were building a house for some reason, some kind of shelter. It absolutely will work, and it does make sense. If all you had was, I don't know, some way to measure something, you could do this without having, with using this rule. Pythagoras, he was a Greek mathematician, and he discovered the rule. I don't know that you need to know this, but you might for a quick quiz. Pythagoras, I think I spelled that right. Okay. That's an A. Greek mathematician. Mathematician. And I don't know if I spelled that right either, but I think I did these 2 backwards. But he discovered the rule back in, it doesn't say. I think it was BC. I can't remember. But he discovered this rule. I remember when I took my math history class, the way he came up with this rule, he was sick in bed, he was confined to bed, and he saw flies up on the ceiling. And he realized he saw these flies, and there were 3 flies, and he literally somehow calculated that the distance of the 2 legs, this leg A and B, would equal to C, which I thought was pretty cool. I mean, I don't know, he's a math genius, and I'm just trying to get by here. But anyway, he realizes that the sum of these 2 legs were equal to this leg. So with that being said, we're going to get on into the rule. I always call it theorem. If I call it theorem, I'm sorry. That's the way it was when I was in high school. So now they call it the Pythagorean rule. And the formula, this is the easiest formula you're probably going to learn in my class. One of them anyway. A squared plus B squared equals C squared. So you have a triangle. And this has to be a right triangle, so I need to point that out. I don't think it will work unless it's a right triangle. And what it is stating is A and B, they're legs of the triangle. A and B are 2 legs of this triangle. And C right here is the longest opposite the right angle. C is opposite the right angle. That leg is called the hypotenuse. Now that's a big word, but again, hypotenuse C is a very special leg because the sum of these is equal to the sum of that. A squared plus B squared equals C squared. So if you know legs, you can find the hypotenuse or the C. If you know a leg, you can find the hypotenuse. So it's relatively easy formula. A squared plus B squared equals C squared. And C is always the hypotenuse. It's very special. Now I want to point out something to you right now. You can add in any order. So even if you mess up these 2 legs, 3 plus 4 is 7. 4 plus 3 is 7. So you really, if you have the legs, you really can't mess this up. You know, you don't have to get all excited about which leg I'm putting in or which value I'm putting for A and B, because it's going to work in this case because commutative property of addition says I can add in any order. So that's pretty cool. So this formula should be relatively easy. Now, the first example they give you is you have to find the length of the hypotenuse. The legs are 5 and 12. So they tell you the legs, and this is the example in the book, legs are 5 and 12. So again, you don't have to obsess about the order. It doesn't matter. My rules are write the formula down. A squared plus B squared equals C squared. Plug in the values. So here all I did was I plugged in 5 and 12. Now you have to square them. To square something means you multiply that number by itself. So 5 squared means 5 times 5, which is 25. And remember, order of operations say I've got to square before I can add because, please excuse being an exponent. And then 12 squared is 144 equals C squared. Now we're trying to solve for C. So then I add last. So 144 and 25. Okay, I thought I was right. 169 equals C squared. I went to the side and did it instead of trying to do it in my head because I don't want to make this mistake since I'm on video. But here's the deal. This is squared. We got to get C by itself. Remember in algebra when we're solving letters, we want to do opposite of what's going on. So the opposite of something squared is the square root. So remember, balancing the equation, we have to do it to both sides. So to get C alone, we have to take the square root of 169, and you have to take the square root of C squared. Now, the square root of 169 is 13. And you may have to jot over to the side your perfect squares. 1 squared is 1, 2 squared is 4, 3 squared is 9. You may need to jot those down because 12 squared is 144. You might need to get to the next one, which is 13 squared. This is a review for y'all because we've done some of these. But the square root of C squared is C. Because when I multiplied exponents, I added the powers. So literally, the square root of C squared is C. And it's going to be every time. I don't want you to get too excited about all that. You literally are dividing by the power there. But it's okay. You're going to get a lot more into that in algebra, so don't get too worried or worked up about that. Most students don't really have trouble with this. When you have the two legs, it's actually a pretty easy section. Hardest part, I guess, is trying to remember the formula. But again, ABC, they're squared. You ought to have it. So number one, we'll do number one. And you've got this triangle with 3 and 4. So here we go. On number one, you've got a triangle with legs 3 and 4. I'll draw it out for you. Triangle. My triangle's not too straight. All right, we've got a leg that's 3 and we got a leg that's 4. Again, you're trying to find C or hypotenuse. So write the formula down. Plug in the values for the legs. It doesn't matter what order. Now, raise to the power, or square it. 4 squared is 16. 3 squared is 9. 16 and 9 is 25. Again, you've got to take the square root of both sides because we got to balance the equation. If you do it to one, you got to do it to the other. So 5 is your C. So 5 for C, that would be that leg. You can actually plug it in and check it if you want to. I'll do that for you really quick. 4 squared plus 3 squared is equal to 5 squared. 16 plus 9 is equal to 25. Yes, 25 does equal 25. It checks out. So what I did, again, I just wanted to check and see if this value actually did work for the equation. And I plugged it in there to show you that 25 does indeed equals 25. So the value is 5. So 3 and 4 and the leg 5. So if you think about the whole fly thing, how he did that, I don't know how he figured it out, but pretty cool. And it works every single time. So a long time, I think they called it a theorem, and then it became a rule because it literally works every single time in every circumstance. When you're getting on up into squares, you may have to, like I said, you may have to jot some down over to the side to try to figure out the perfect squares. But there's also a page in the back of the book, I'll look it up in just a minute, where you can find the table of squares. If you forget one of them, like even 13 is 169. I know most of them. I don't know all of them. But anyway, there is a table of squares that you can look them up on. It's in the back of the book, and I'm trying to look really quick. Okay, table of squares and square roots is on page 419. So the table of squares and if you need to look to it, that's fine, is on page 419. Because you might forget some of them, and some of them are pretty large. So I didn't give you a calculator, so I am going to give you a table of squares. And also on the test, you're going to have that table of squares. So if you forget one, it's not really that big of a deal. So let's try to do, okay, well, I'm going to do number 4 with you because it's pretty large. And I think that's the easiest one. You got 45 inches. You got a triangle that's got, I'm going to hold my book because I can't remember all this. So number 4, and I'll do this one with you too. You've got a triangle. Again, a right triangle. And you've got, this leg is 45 inches. This leg is 60 inches. And you've got this triangle Z, okay. X, Y, Z, because that's the way they do it. So write your formula down. A squared plus B squared equals C squared. Plug in your values. 45 squared plus 60 squared equals C squared. Now, you can go to the table of squares, which might be the easiest thing. I know 60 times 60 is 3,600, so that one's pretty easy. 45 squared, I really don't know it off the top of my head. I probably can multiply it out really quick. I'm going to look and see if it's on the table of squares. And it is. So, look to your table of squares and you'll find this is 2025. This is 3,600. And that'll help you just, you know, you can go, like I said, and you can multiply it out and get it. But it will be a little bit easier for you if you look on the table of squares. These are just because, remember, hunt and see. This is just for the really large one. Most of them you know. Well, you know 6 times 6 is 36. Add the 2 zeros, 3,600. Y'all know how to do that. So you can go add these two together. 3,600 plus 2025. And it's 5,625. 5,625 is C squared. Now, you have to take the square root of both sides. Because remember, we're trying to get C by itself. So C is equal to, again, I have no idea what it is. We could extract the square. We could do guesstimation. But we have a chart back here, so I'm going to see if it's on my chart. It goes up to, and it may not be on here, 56. It is. It's a beautiful thing. It's on the chart. The square root of 5,625 is 75. So, again, use that chart. I don't remember them all myself. But you have that, and you'll have that on the test. So, that is section 9-1. And that's a lot so far. But we're going to section 9-2. We're actually using the same rule. Except now you have, let's see, using the Pythagorean theorem, find the length of legs. So what happens here is, in section 9-2, we're going to try to find a leg. So we've got to, if you're finding a leg, you have to have the hypotenuse and another leg. So, same formula, but we're going to do a little bit different on the math because we have different information here. So, the easiest thing for me to do is to get right back into it. You're using the same formula. And we're going to do number 2 as one of your problems. You have 1 through 10 all, so we're going to do number 2. And they have a triangle. A right triangle. This one's 8 inches. They give you the hypotenuse is 17 inches. Remember, the hypotenuse is the C. It's always opposite the right triangle. So what happens is we need to find what this other leg is. And you can call it A, B, or C. I'm going to just put B there because we got to find another leg. It doesn't matter. It's not going to matter. So, you write the formula down. a squared plus b squared equals c squared. Now I have a leg. I'm going to pretend I have a. Like I said, you can try it for b. It doesn't matter. We know we have c because c is the hypotenuse. So, in the place of a, I'm going to put 8. Well, there's nothing to plug in for b. We're trying to find b or the other leg. And c is 17 squared. So, 8 squared is 64. And b squared is 64 plus b squared. And then 17 squared is 289. So, we have 64 plus b squared equals 289. Now remember, you got to go back to your algebra. You're trying to get the letter by itself you're trying to solve. So you have to think opposites in algebra. So this 64 is added to this b squared. Well, I've got to get b by itself. So remember, the opposite of addition is subtraction. So I literally have to subtract 64 to get it to go to the other side. Balancing the equation says if I subtract it from one side, I have to subtract it from the other side. So b squared is equal to 289 minus 64, 225. Let me do it to the side. 289 minus 64. Yes, 225. Just wanted to make sure. So, you have to, at that point, you've got b squared by itself, but we had to get b by itself. So, you have to take the square root of both sides. B is equal to, I believe it's 15. I'm going to check. Yep, 15 inches. And again, you can always check your table of squares if you want to. So the hardest thing here is, or the only, I wouldn't say hard, but you have a little more algebra because you're going to have to subtract off that other leg and then take the square root, where before all you had to do was sum them and take the square root. So again, we need to be reminded, one leg is A, B, C. So, leg A, leg B, leg C. Again, try to remember that's the hypotenuse, because that's the special one. It's always the C, and it's always opposite the right angle. So that's a big deal, because it does matter about the C. So let's try another one. I guess we can do number 5. Okay, number 5. They give you on this one, let's see here, leg 7. Oh, no, let's don't do number 5 because that's the original. We've got to find one with a leg. So, let's do number 9. So, on number 9, they give you a chart and they give you legs and then they give you a hypotenuse. So, number 9, what happens is they say one leg is, we don't know. Then the next leg is 8 inches. And then the hypotenuse they give you in number 9 is 11 inches. Okay, so you've got some leg you don't know, which is what we're trying to figure out. Then a leg and the hypotenuse. So, again, hypotenuse is C. So, A squared plus B squared equals C squared. You're using the same formula every single time. So, because this was the first leg, I'm going to just say A squared. B, H squared. C is 11 squared. So, A squared plus 8 squared is 64. Y'all know that. And 11 squared is 121. Okay? Still, we don't know this leg. We've got this leg added. You got to go do, what's the opposite of addition? Subtraction. So, I've got to subtract the 64. So, subtract 64 from both sides because you have to balance the equation. Okay? A squared is equal to 121 minus 64. The 57. Okay, that, as you can see, is not a perfect square. I'm going to look it up and see if it's in the back of the chart. And I think it is the square root. Oh, it's 56. No, wait a minute. It is 57. Let's see if it's in the back of the chart really quick. Square root. It is. Okay, yeah. So all you got to do is look at the back of the chart, and it's there. Take the square root of a squared. Take the square root of 57. And it is 7.5. I want to see if they say anything about rounding. It says on here, round to the nearest tenth. So that's what it is, 7.5 inches. So here's the deal. If you have a weird one, okay, if you're going with squares, you know, 7 squared is 49. 8 squared is 64. So you know it's between 7 and 8. You can kind of guesstimate it, but you don't have to because you got a table of squares. And just be careful on this because it's got on that back chart, it's got the number, the square, and the square root, and there are numbers up to 150. So it's quite a bit of numbers. I had to scale through there and look at them to find this answer. And it says in your book to round to the nearest tenth. So that is the first two sections. I know it's a lot. We're moving pretty fast because if we were at the co-op, we'd be trying to get through the book. But those are the first two sections. And honestly, today is Wednesday. I think that I will try to not post 9-3 until tomorrow because it's quite a bit. And it's exciting. You know, a lot of my students really love this. And I think it's fun. I think it's cool that this works out. Like I said, if you were in the woods, you could literally measure, you know, if all you had was a 1 foot, you could use this formula and you could start your structure of your house because houses are 90-degree angles, right? And you could literally go ahead and use this theorem to start your walls or just start your foundation using this. So you could use just a regular foot or measuring rod and you could get this. So I think that's kind of cool. I think actually, I'm not sure about this, but I think the Boy Scouts probably have very limited means and they've probably had to use something like this to work it out. But anyway, I hope y'all are having a great day. I know you're getting a lot of time at home. If you're like me, we are not going out to eat. We are staying in. My kids are really sad about that, but we're getting some good family bonding time. And I'll see y'all tomorrow.